Hello everyone and welcome to our educational session. My name is Paul Arsov and I'm the founder of the Decentralized Web project. The topic of our educational session today is analyzing the fundamentally elusive elements of intelligence. The topic touches on technology and also on psychology, and it has application in the current leading edge of technology based on artificial intelligence offers. Intelligence is often lauded as humanity's defining feature, yet its fundamental nature can be elusive. One fruitful perspective is to view intelligence primarily as the capacity for pattern recognition. Mathematicians formularize patterns with the language of group theory, which captures and categorizes symmetries. Yet, even where patterns abound, a researcher called Stephen Wolfram's concept of computational irreducibility shows that some processes defy any shortcut to prediction and understanding, thus placing a fundamental bound on how quickly and easily even superintelligence might discover reducible patterns and disassemble the complex thing into separate pieces. In what follows throughout this presentation, we are going to explore the connections between intuition, symmetry, group theory, and computational irreducibility, and the possibility of cognitive capacities for exceeding our own, ultimately leading us to the monster group, which is a mathematical colossus that symbolizes in many ways the inconceivable extremes of pattern recognition and the potential limits of computation and cognition. Intelligence as pattern recognition, at its core, intelligence can be seen as the ability to learn, identify, and predict structures in our environment, whether it's a toddler learning to recognize faces, or a scientist spotting trends in data, or a chess grandmaster foreseeing tactical motives on the board. The unifying trait is pattern recognition. From an evolutionary perspective, we honed these abilities to survive in complex habitats, instantly distinguish friends from foe, or predators from prey. In day-to-day life, we typically call these rapid judgments and insights intuition. Intuition feels almost magical in its speed and certainty. Under the hood, though, it's ultimately tied to the brain's proficiency in matching current situations against familiar templates. The process is so refined that we rarely notice the immense computational feats going on behind the scenes. In technical terms, the mind excels at spotting repetitive structures and categorizing them for future use. Formalizing these idea in mathematics leads us to group theory. A group is a set of elements along with a binary operation uh, satisfying four conditions: closure, associativity, identity, and inverses. Well, this definition might seem very abstract. Group theory is in fact the language of symmetry. Closure is performing one symmetry operation after another remains with the same set of transformation. Associativity is the order in which we apply symmetry operations that does not alter the final outcome. Identity is about this do-nothing symmetry which leaves an object unchanged, and inverse is every symmetry which has a partner operation that undoes it. For example, consider a square and its symmetries: rotation by 90 degrees, rotation by 180 degrees, by 270 degrees, and 360 degrees, which returns it in the original position, and reflection across various axes. All such movements from the dihedral group of order 8 Similar ideas apply to more complex objects or abstract algebraic structures. If we can describe all the transformations that preserve some property of a system, then we have a group. Thus, when we talk about recognizing patterns, we are often talking, at least in a rigorous mathematical sense, about recognizing group actions, how certain transformations reorder or reshape an object while preserving its essential structure. Yet humans can only intuitively grasp fairly simple groups like those describing polygons or cubes. On our mental apparatus, shaped by natural selection, simply does not scale well to the immense combinatorial complexity of large or extremely abstract groups. Our intuition is powerful, but far from limitless. Day-to-day life rarely demands us that we conceive of the astronomical complexity found in advanced mathematics. As a result, visualizing very large or highly abstract finite groups with a vast number of elements or intricate structures quickly outstrips our natural computational capacities. For instance, we can handle the geometric group of a cube by mentally picturing 90 degrees rotations in 3D space. But we struggle with molecules symmetry group if it involves multiple axes or higher dimensions. We're utterly lost when grappling with truly gargantuan groups that offer no intuitive mental picture. Human brains evolved to analyze and predict patterns that appear in the environment that we inhabit, for example, tracking animals, forging social appliances, finding edible plants, not to unravel the monstrous symmetries hidden in abstract algebraic structures. Yet even before we reach the heights of infinite or sporadic group, the researcher called Stephen Wolfram's principle of computational irreducibility introduces another set of boundary. Wolfram argues that certain systems, be they cellular automata, natural process, or abstract computations, cannot be shared and shortcutted by any closed form or simplifying trick. To predict a system state at a given point, you must efficiently run the computation step by step. In the language of pattern recognition, computational irreducibility tells us that not all phenomena exhibit neat symmetries or easily predictable structures. Some processes do not yield to durations, no matter how clever the algorithm or how powerful the intelligence is. In the universe or large swaths of it, computational irreducibility can bypass certain brute force explorations. Irreducibility means a lack of deeper symmetry from which shortcuts may arise. Even superintelligence may need to do the entire work of allowing a process through all of the strategies to know the outcome. The complex and the concept highlights a fundamental limit in discovering and utilizing reducible predictions. Where symmetries exist, group theory often helps to compress the process, checking every possible pathway, but without no meaningful symmetry can be found. When computational irreducibility reigns, no one is forced to do the the notion of a superintelligence, an entity whose cognitive powers vastly excels those of humans, raises the question of whether such a mind could transcend the bounds of intuition and systematically find patterns we consider currently hopelessly complex. A being or a machine intelligence and endowed with far greater memory, processing power, and more flexible measuring might in principle. Therefore, is, however, no large finite group that can be constructed in arbitrary large forms, each with unique internal symmetries. A superintelligence might climb this hierarchy of groups with apparent ease, discerning structure and scale that we cannot fathom. Yet, Wolfram computational irreducibility implies there could be structures so unstructured, so lacking in symmetries, that even superintelligence would leave no choice but to proceed step by uncompressible step. Hence, when we speak of unbound intelligence in the realm of highly symmetric or complex but structured systems, it might do far seemingly unimpeded. But in the realm of irreducible systems, everyone from humans to superintelligences may face the same brute force necessary at the summit of complexity in finite group theory, such as the monster group. Among the 26 so-called sporadic simple groups, the monster dwarfs the others. Its order or number of elements is 1, the order of yet it isn't the raw size alone that makes it remarkable. There's a deep web of connections, often referred as structure monstrous moonshine. Trying this algebraic behemoth in areas of numbers theory, modular forms, or even theoretical physics, such as string theories. For human mathematicians, comprehending the monster group theoretical insight, there's no direct mental picture of it. Its structure is far too immense and intricate. This is why some set of monster group as symbolic of cognitive limits. The intelligence that truly sees the monster group at a glance, instantly grasping its structure, may be so far beyond us so that it appears almost divine. In pondering the bounds of intelligence, mathematicians and computational providers have a dual message. On one hand, group theory shows an infinitely many layers of symmetry to explore, and an even more powerful mind that could climb the rounds in dazzling heights, grasping monstrous groups with an apparently effortless intuition. On the other hand, computational irreducibility warns that some process admits no simplifications. No matter how refined or vast the intelligence is, the system may have to be run step by step to predict its behavior. Thus, while group theory and its symmetric uh, beckon towards the concept of unbounded or even ever-expanding cognition, we must also account for limits imposed by irreducibility, where all predictive structures evaporate. The Monster Group stands as a great testament to the extraordinary structures lurking within mathematics and to our finite capability to grasp them. Whether it is superintelligence may integrate these extremes, uncovering all expiring symmetries while running irreducible computations in the background, is a profound question bridging the depths of mathematics, computer science, and cognitive theory. In the end, human intuition is finite, and some phenomena are irreducible. The kind or the kingdom of mathematical patterns remains boundless, shimmering of scale, both tantalizing and forbidden to our limited sight. And with this said, I'm ending this educational presentation, and I'm coming back to this presentation when I told you that my name is Paul Arsov, and I like to tell you about several projects that we are working on. The first project that I want to mention is the Decentralized Web project, and in this Decentralized Web project we have our blockchain instance, and we're building a platform which could be and is monetized through advertising. The user who comes to our platform gets rewarded in tokens for joining the platform, for referring other users, and for viewing advertising. The website and the URL of this project is decentralizedweb.org. Decentralized and web, these are two words, they are typed all together, and then there is dot, and it ends with org. Once again, decentralizedweb.org. The second project that I want to mention is marketplace and collection of NFTs based on three-dimensional object. The 3D NFT project has its own software, like 3D software engine, which we did build specifically for the project. Unlike standard engines which 3D object creators use, we did decide from the very beginning of our project to build our own 3D software engine. What it does is it reads the object of the 3D, the file of the 3D object, then it opens a window on a computer screen. It displays the 3D object in this window, and then it starts animating the 3D object of the 3D NFT in a way of moving it in a random fashion around the window it did open. But in addition to this initial capabilities of loading, animating, displaying and animating of 3D NFT, our 3D software engine has multiple additional capabilities. The first additional capability of our 3D NFT is the capability of speaking. The 3D NFTs can speak in one of three different voices, be it a male or a female or a whisper kind of a voice. In addition to the three basic voices, there are three different flavors. A voice can be spoken in a normal speed manner, or in a fast speed manner, or in a slow speed manner. If we take a male voice and it is spoken in a slow speed manner, then this voice can come as the voice of a very masculine person or the voice of an old person. If on the other hand we take a female voice and it is spoken in a fast speed manner, then this voice can come as the voice of a funny person or the voice of a little girl. The next additional and important capability of our 3D NFTs is the capability of voice recognition. If, for example, we have a 3D NFT which is moving, being animated in a random fashion, then we can issue our very first voice command to the 3D NFT to stop moving. And then the 3D NFT is going to stand still and stop moving. Then we can issue following voice commands to the 3D NFT to move left, then move right, move up, then move down, zoom in, zoom out, rotate. And then the 3D NFT is going to fulfill each one of these separate voice commands and move left, then move right, move up, then move down, come closer, zoom in, go further away, zoom out, and start rotating. The next additional important capability of our 3D NFTs is the capability of them having a basic artificial intelligence. Wow, really? Wow. You can ask the 3D NFT what is your name, and then the 3D NFT is going to reply in few sentences with their name. You can ask the 3D NFT who are you, and then the 3D NFT is going to tell you in few sentences about who they are. You can ask the 3D NFT to describe something. For example, describe Web3, or describe decentralization, or describe Russia. And then the 3D NFT is going to describe in few sentences about Web3, or about decentralization, or about the country called Russia. The last additional but not least important capability of our 3D NFTs is the capability of them being displayed in a way of stereoscopics. So what stereoscopics means is that part of the 3D NFT is going to be displayed in red or reddish colors, and another part of the 3D NFTs is going to be displayed in blue or bluish colors. Then you can come to our 3D NFT website, and probably now is the time to tell you the name and the URL of the 3D NFT website and marketplace. It is 3dnft.decentralizedweb.org. 3D NFT is typed in a way of the number 3 followed by the letter D followed by 3 other letters NFT, and it is typed all together 3D NFT. Then there is dot, then there are two words which are typed all together, decentralized and web. Then there is dot and it ends with org. Once again, 3D NFT dot decentralizedweb.org. On the top of the main page and every other page you can see a number of links. One of these links is pointing to accessories, and when you click on this link you're going to see that we're offering special glasses. When you order one pair of these glasses, you're going to see that one lens of these glasses is red, and the other lens of these glasses is blue cyan. Then you can put these glasses on. You can request displaying of the 3D NFT in a way of stereoscopics, and then you're going to see the 3D NFT is coming out of the flat two-dimensional computer screen, and you're going to see it in real 3 dimensions. With this said, I'm ending talking about our 3D software engine and collection of 3D NFTs, but I like to tell you a little bit of our marketplace. In our marketplace, we have our own blockchain instance. It runs Ethereum software, and it is the same software which runs on Ethereum mainnet. It runs on Binance Smart Chain Net. It runs on Polygon Matic chain. It runs on Avalanche AVAX chain, and it runs on many other famous or not so famous blockchains in existence. Like by having our own blockchain instance, then we do not require our users to pay gas fees for the deployments of the smart contracts of the non-fungible tokens, and our users do not pay gas fees for transactions of transfer of ownership from one user to another user. Also, by having our own blockchain instance, then we allow our users to buy 3D NFTs and receive proceedings from sale of 3D NFTs in multiple crypto coins. Currently, the choices of crypto coins include 4 different choices, namely Solana Sol, Polygon Matic, Avalanche AVAX, and KuCoin, which is a big centralized crypto exchange. They have a coin called KCS. In addition to buying and receiving proceedings from sale in crypto, we have a second parallel and independent way of buying and selling of 3D NFTs, and it is done entirely in fiat currency. For example, if you're the user, you come to our 3D NFT marketplace, you browse through the collection of 3D NFTs, you click on one 3D NFT that you like, and then you're going to be presented with a drop-down menu asking you to select between 4 different choices of crypto coins and the 5th choice of paying with fiat currency. So let's say you select this choice of paying with fiat currency. You click on the button to advance next, and then you're going to be presented with a screen where you have to put the number of your debit or credit card, CVC, expiration date, and when you click on the button to complete the transaction, what is going to happen is there is going to be a transfer and a transaction and conversion between your national fiat currency, which could be different than US dollars, and the transaction is going to convert from your national fiat currency to US dollars and deposit the transfer in our bank account. Then we're going to follow this action with the second action, and we are going to be having a transaction of a transfer of ownership, the initial ownership from our 3D NFT marketplace to you, and now you're becoming the owner of this 3D NFT. Let's say you play for a while with this 3D NFT, and then you decide to put this 3D NFT for sale. You decide on the price that you want to sell this 3D NFT, and let's say there's a second user who comes to our 3D NFT marketplace. They browse and they see in particular the 3D NFT that you put for sale. So what is going to happen is the second user is going to go through the same step of choosing between 4 different crypto coins and fifth choice of paying with crypto. So let's say they select paying with fiat currency, and then they are going to be presented with a screen of where they put the number of their debit or credit card, CVC, expiration date, and then they complete the transaction, and the transaction is going to be a transfer and conversion from national fiat currency of the second user, which could be different than your national fiat currency, and this transaction is going to convert the payment in US dollars and deposit it in our bank account. Then we are going to make a transaction of a transfer of ownership from you, the initial user, to the second user. Now the second user becomes owner of this 3D NFT. Then we are going to have a third action, and a transfer and conversion from US dollars to your national fiat currency, and this transfer is going to be deposited in your bank account in your national fiat currency, and with this set I am going to end talking about the second project. I like to mention the third project that we work on. The third project is about electric vehicles, and we're building products which are going to be charging electric vehicles, and we estimate that currently electric vehicles are going to be handled in a way which is similar to gas station model, where internal combustion engines come to the gas station, they connect fuel hose to their fuel tank of their vehicle, they start loading gas, they pay for the gas loaded, and they leave. In the same way, currently there are number of charging stations with which has several electric vehicle charging columns, which where the user can connect a charging cable to their electric vehicle. They could wait for a while their vehicle is charging. Then they can pay for the electric energy which was loaded in their electric vehicle, and then they can leave. We estimate that the number of these charging stations, mainly built in cities, is going to become ultimately insufficient to handle the exponential growing number of electric vehicles. That's why we are proposing a different model, and we call this model the parking lot model, where number of products the products that we're building could be mounted at parking lot locations, and owners of electric vehicles which are living in residential buildings which has ground floor parking lot or multiple on the ground floor parking lots. They would come to with their electric vehicle in the evening after work. Then they can connect electric cable to their electric vehicle. They can identify themselves by their debit card or credit card, or special near-field communication card, or special near-field communication keychain token, or special near-field communication ring to the charger. The charger could then turn on and provide electricity to the electric vehicle, and the electric vehicle could be left charging during the evening, during the night and early morning, while the owner of this electric vehicle is at home in their residential high-rise building. But multiple owners, many owners of electric vehicles, they could be going to work in an office which is a high-rise office building. In the same way, the high-rise office building could be outfitted with electric vehicle chargers, like the type of charger that we're building, and this high-rise building could be offering the workers which work in the office building to connect charging cable to their electric vehicle. They can identify themselves by their debit card, credit card, or near-field communication card token or a ring, and they could leave their vehicle charging during the morning, afternoon, and early evening, while the person who is owner of electric vehicle works in the office building. With this said, I like to tell you the name and the URL of the website of this project. It is power.rstack.com. Power is the ordinary word for power, then there's dot, then there's a word which I can spell it letter by letter. It's Alpha Romeo Sierra Tom Echo Charlie Hotel. Altogether rstack. Then there's dot and it ends with com. Once again, power.rstack.com. On the main page of this website, we're putting a number of surveys. Currently, we have 3 different surveys that you can click and you can fill. One of these surveys is on hardware, the other surveys in the software, and the third survey is about the future of charging electric charging products. By filling a survey like this, you can tell us about your needs, and then we can maybe customize an existing product or build special product for your needs. In addition to this, we did post an URL and the name of the article, which compares gas station model versus the parking lot model. In this article, you're going to see details on additional details on the products that we're building, and probably now is the time to tell you that the products that we're building are going to include between 2 to 4 charging cables. It is going to include high voltage and high current electric switches. It is going to include Wi-Fi connection capability, so that this charging station can report this to a central body, like the owner of the office building or the electric utility, for example. And our products are also outfitted with near-field communication reader and like a current measuring device, which can calculate the exact amount of power which was charged through the time of charging of the electric vehicle. With this said, I'm ending talking about this third project, and I like to tell you about the fourth project that we're working on. The fourth project is called AI to AI project, and in this project we have like 2 artificial intelligence entities, which are based on 2 different large language models, and each of these 2 different entities have their gender, be it male or female. They have specific voice pitch for the voice of the interaction between these entities, and in this project, the human user is just an observer between the interaction between the AI entities. And the user is in general selecting the parameters of these AI entities, and it selects also the avatars, it selects the initial prompt and context for the AI entities, and defines the interaction. The interaction could be, for example, be very seductive, or be very angry, or sell, for example, a washing machine to the other AI entity. And then the user can start this interaction between 2 entities and enjoy and be entertained of this interaction as the AI entity talk to each other. And then the user at some point can end this interaction, and at the point of ending, the user could save this interaction for future viewing, and the user can like share this interaction, and this interaction can be posted on our AI to AI website, so that other users can see the parameters of the interaction that you just observed, and have an interaction which is not identical but similar to the interaction that you just had. And finally, you, the user, could be having a log of the interactions that you did, and the log shows you the number of minutes that you had for each interaction, and it shows you the billing in minutes for and the remaining amount for that you have for as a credit. Initially, every user is given a credit of $1, and they can refill the credit with a minimum of $5 without limit of the maximum, and have this interaction continued, and they can pay with their debit or credit card for refilling of their user account. With this said, I like to tell you the name and the URL of the website of this final project that I like to mention. It is ai2ai.decentralizedweb.org. AI to AI is typed in a way of the letter A followed by the letter I, followed by the number 2, followed by two other letters A and I. And altogether, this is AI to AI. Then there is dot, then there are two words, decentralized and web, and they're typed all together. Then there is dot, and it ends with org. Once again, this is AI to AI .decentralizedweb.org. With this said, I'm ending this presentation. Thank you for listening. Thank you for viewing. Have a nice day. Have a nice evening, and goodbye.